Okay, so we did this one. We did that one. So here's the word problem where I quit. So I didn't like how the lesson had been going. So let's see. So a rope is fastened. So we're given that this distance is 8. This round shape, the cylindrical container. So we're being told it's right in the middle. It's stretching the rope as far as it can go, the center of the container, so the distance ED is 3 feet, and we want to know what the distance is of the rope if you go all the way around from A to, and they didn't label this point for some reason, but that's what we're interested in. So let's first figure out if we can come up with what do we need to figure that out. So how do you find that distance L? Like if I can split it into parts that I know, and one of the first things that I can do is, if I cut this in half, would you agree that the bottom half is the same as the top half? Alright, so I'm just going to concentrate on the top half here, and this is why they didn't label this point over here, but I should be able to find the length just by finding this thing over here, the distance from A to C, and multiplying by 2. Okay. How can you split up the distance from A to C into parts that we know? AB, which is just the length, right? And that would be side of, because it touches here, what do you know about this angle here at B? Yeah, it's a 90-degree angle. Okay. So AB is just a leg of a triangle, so Pythagorean theorem should probably work there if I can somehow find some more information about these sides. Yes, which is, they sort of gave us that. So that's right. So I need one more of them, right?
Yeah.
Okay. And then what's the distance BC? Well, the distance BC is what? That's an arc length, right? So we have a formula for that, so I need to find some information about BC. I already know the radius. Michael just said that that's 2, so that will work for that part. I just need the central angle. So let's go back to AB. Okay, so AB squared plus 2 squared is AE squared. Are you guys okay with that based on that triangle? Alright. What can I do? Is there any way to find AE, maybe? Give you a hint. That's a right angle. Do we know the distance from D to E?
3.
And the distance from D to A is?
4.
So this distance from A to E is?
4 squared plus 3 squared.
And then the square root of that?
Yeah.
5. Good. It's a 3, 4, 5 triangle. But so AE is going to be 5. I don't want to write it in here because it's going to mess up the picture.
E is 3?
Yes.
Okay.
Yeah, it's marked. I understand your confusion a little bit. So where did they tell us that? If the center of the container is 3 feet away from the point on the wall, midway between the ends of the rope, so center to D is 3. So I don't like it. The 3 would have been better here, right? And the 2 would have been better if it actually was over here, but then it gets in the way of theta. So that's why. Okay, so I can solve for AB, can I not? AB squared will be AE, which is 5. 5 squared minus 2 squared, right? So AB will be the square root of, right, 25 minus 4 is 21. So that works. So that's one part. Okay, that was the easier of the 2. So let's see how can I get to theta somehow? Now keep in mind that you now have a right triangle here, right? And you know 2 sides. So is there a way to find this angle here?
Yeah.
I think so. Okay, so I think that I can find angle DEA, and I'm just going to abbreviate this with an E1. Okay, so if this is E1, then that angle E1 can be found, I think. What can I use for that? How can I use the 3 and the 4 to find that angle?
Tangent.
That would be the tangent. So the tangent of E1 is opposite over adjacent, right?
Yep.
So the angle would be the tangent, inverse tangent, sorry, of 4 over 3. And I did all this in degrees. You could certainly do this in radians as well. I think initially it might feel a little better for yourself if you do this maybe in degrees, because if I wrote the radian measurement here, that would be 0 point something. I think that would be sort of awkward. What was that?
That was like 0.9.
Yeah. So that feels a little awkward maybe. And if you're comfortable with it, then you can go ahead right away and use radians, because ultimately this angle needs to be in radians to use arc length. Okay. So that's another one. So how about E2? Can I find out what E2 is? Keep in mind that you have the distance from A to B now.
Yeah.
I think, yeah. So how do you find that one? So, and actually I have it labeled now, so I'll just call it angle E2. So looking from E2, you have an opposite and an again, so you can use what again?
Tangent.
Right. Okay. So the tangent of E2 would be the square root of 21 over 2. So E2 is the inverse tangent of that thing.
66.42.
Okay, 66 point, and we'll round to 1 here. All right. So Connor, how can you find theta then? How do you find theta? What do we know? Do you have any idea how to get to the angle that they marked here with the theta? So why do you think I found E1 and E2? What can I do with E1 and E2 and knowing that this is a straight line?
Add them together and then subtract that one.
Yeah, so theta is the 180 minus the two things we just found, right? So that means that theta is 180 minus that mess is 60.5. And then Taylor, why in the world did we do all this? Why did we need it? Right, why did I need angle theta? Keep in mind sort of what was the idea here. What were we trying to find? And I maybe should have put it in a different color, but it's right here. The length, right? And we found AB, and then BC is what? I put a little half moon on there because BC represents an arc length, and theta will help me find it, right? Okay, can you tell me how to find BC, knowing now that what theta is? Arc BC is what? Did it for the bell work. The formula for arc length is? So this is RS. R times theta. And what is the radius? Radius is 2. Okay, and then I do have to convert theta to radians, right? So if you had done all this work with your calculator in radians, so this would be radians, that would be radians, then this answer would be radians as well. If you had used what here? Instead of using 180, if you had done this in radians, what would you need here? 180 is how much in radians? Right. If you did this in radians, you would do pi minus then this mess in radians. Okay? So somewhere along the line you have to sort of convert some stuff anyway. And I actually prefer to do this in degrees because it just, even though I use radians enough, I don't really know, like 1 radian, how many degrees is that, what does it look like, I just don't feel comfortable with it, so I just usually do it here. Did you just come back to school?
Yes.
Okay. Did you check in?
Yeah.
Don't worry, I'll let them know at some point. So our length is twice, and AB was the square root of 21. Yep. And BC is 2.11. So put that in your calculator, and you should get 13.4 feet. These are the notes we started on Friday when I did a horrible job, Cam. So I quit, and this is the word problem. So you can follow along with the second one here in just a sec. Are we okay with this example? Anybody other than Cam? Can I move on? Okay. Next one then. So we have two belt pulleys. They give us the radii for both of them. So one is 5, one is 8, 15 centimeters apart in the centers, and we need to find the total length of the belt around the pulleys. Now they already gave us the first hint. This may not be given in a word problem. So what they did is they drew a rectangle here by, like if this whole radius here was 8, if you go out a circle, if you go out the radius, how do I say that? So that one's 5, this one's 8. You do 8 minus 5 is 3. So you draw a new little circle in here, and then if you make the line from A out to C, you know you should be tangent to the circle at that point. Does that make sense? A little bit? So let me try to draw this, then I'm going to erase it. So here's the 5 one with the center. That's way too big, but okay. Here's the 8 one. So this line here has a 90-degree angle, right? Because the belt pulley, the belt touches. So this is a 90-degree angle, and this one is 90 degrees as well. So you have two 90-degree angles. So if you make a line that's parallel to the line over here, then you force this to be a rectangle, right?
Yes.
Okay. Well, if this one's 5, then how much does this one have to be? Well, then how much does that leave you for your radius here? 3. And that's where it came from. Does that make more sense now? Okay, so this is why they drew a dotted rectangle in the middle, so that we would have a rectangle there, and that's going to help us find some other stuff. All right, so I'm going to erase all that because I might need it. Actually, I know I'm going to need it. So again, we have a symmetric shape, so I'm just going to find the length from D to G. Okay, that's the length I'm interested in, and then I'm going to multiply that by 2. So what does that length consist of? DE is what? It's a arc length, right? So I need to find arc DE plus EF, which is just the length, plus arc FG. Okay, so finding 3 pieces of information on this one, multiply it times 2, I should have an answer. I'm going to start with the easiest one, or what I think is the easiest one, and that would be EF. I can find EF fairly quickly because EF is the same length as AC, right?
Yeah.
And AC is actually, if it's a right angle here, this is also a right angle. Okay, so we have a whole bunch of right angles here, and we force this one to be right. So AC is the leg of a triangle, right? And we know that this one is 3, and the distance from here to here is 15, so you can use Pythagorean theorem again, right? AC squared plus 3 squared has to be 15 squared. And it's a little backwards because usually the legs are on the bottom, but because the right angle is here, AB is actually the hypotenuse. So that means that AC is the square root of 15 squared is 225 minus 9, which is 216. Now to keep in line with the book, so that does reduce to 6 squared is 6. But because ultimately you're going to answer this question with a decimal number anyway, right? Like 82 centimeters or something along that line. You could leave the square root of 216 and it wouldn't matter one bit, because at the end of the day you're going to throw it in your calculator. So that takes care of EF. Okay? Alright. If I can find this angle here, then can I find theta 1 here to get my arc length?
Yeah.
Right, because if this one was 50, then that one would be... Yeah. Good. And do we know two sides?
Yeah.
So the cosine of that little angle, the cosine of x, would be 3 over 15, right?
Yeah.
If I'm in that right triangle, keeping in mind again that if I'm looking here, that's the adjacent, the hypotenuse is your 15, so that angle is the inverse cosine of 3 over 15, and that comes out as 78 and a half, Michael?
Yeah.
Alright. So that means that theta 1 is
101.5.
okay. 101.5. Right. And why did I find that angle again? How is that helping me?
You can put in the radius.
Right? And use that to find,
Arc length.
right. And that will be arc length FG, right?
Mm-hmm.
So FG is the radius, and what's the radius of the larger circle?
8.
8 times this measure, but then it has to be in radians, so here's where the conversion comes in, which is not, this point's really not that big of a problem. Calculator, throw it in, and you get 14.2. So I'm rounding everything here to 1, which I'm fine with, because they really only gave me one whole number, or like 5 and 8 only have one accurate number anyway. Okay, so that takes care of one arc. So how do I find the second arc? So how can I find, so we'll call this theta 2. So any ideas how can I find theta 2?
Do 90 plus 78.5 minus 180.
I think you're on the right track. Are you trying to tell me I need to find this angle here?
Yeah.
And how do you find that angle? So angle A
Minus 78.5.
is 90 minus 78.5. Is that 11 and a half? Did somebody already do that?
Yeah.
Okay. That's one way to do it. You could have just used an inverse from angle's perspective. From this angle's perspective, that's a 3 over 15 is a sine. An inverse sine would have done the same thing. This is probably easier, right? You don't have to even really mess with anything tricky. And then angle theta 2 is 180 minus the 90-degree angle plus the 11 and a half. So what do we end up with for theta 2? What do you end up with? Did you wonder for a moment if that was right because we already used that angle once?
Yeah.
Yeah. They're the same angle, aren't they? This angle here, this little x here, is the same as this one over here. I mean, and the reason for that is because if you look at sort of what we did, okay, y and x add to 90. Does it really matter? Doesn't really matter. You can find it this way. Okay, then what? Yep. Just throw it in, right? So arc DE is the radius, which is 5. Multiply this way, make it into radians by using power over 180, and you got 6 point. And on this one, I guess I did carry a second decimal, so that I have 3 numbers that are accurate. So that you can answer the final question, which is the length. So the length of the whole belt was twice, so DE we just found. EF we found as the first one, and I maybe should have labeled this as EF again. EF is AC, but that's the 6 square root of 6, or the square root of 216. And then 14.2 for your larger arc length. So it ends up coming out as 71.5 centimeters.